Astronomers have identified only 3 objects that are confirmed to originate from beyond our solar system, and the newest of them, designated 3I/Atlas, is already rewriting expectations. First detected during the summer of 2025, the object immediately stood out because it refused to behave like any known comet or asteroid. NASA's Hubble Space Telescope provided the clearest view yet on July 21, 2025, revealing a curious and mesmerizing phenomenon. A faint, luminous haze known as a coma seemed to glow ahead of the object as it moved toward the sun, an effect typically caused when heat vaporizes the icy surface of a comet. But what truly captured the attention of astronomers was not what appeared, it was what was missing. There was no bright, sweeping tail trailing behind the body, the kind of tail that almost every active comet develops as it approaches the sun. Instead, the glow appeared oddly concentrated and directional, almost like a focused beam of light projecting forward. This peculiar configuration immediately raised questions about whether 3I/Atlas could be something far stranger than a simple comet. Among those pondering the object's bizarre nature was Harvard astrophysicist Avi Loeb, a scientist known for offering bold interpretations when data defies conventional explanations. Loeb noted that the intense brightness did not match what astronomers would expect from sunlight reflecting off a distribution of dust grains. Typically, dust reflects sunlight in a pattern that decreases gradually with distance from the nucleus. Yet 3I/Atlas showed an unusually steep brightness drop-off, suggesting that the majority of the light was emerging directly from the object's central body rather than being scattered by surrounding particles. This observation, if correct, would imply that the object is much smaller than initial estimates had proposed, perhaps under 100 meters diameter, placing it in the same size range as the first 2 interstellar objects, Oumuamua and 2I/Borisov. The idea that such a small nucleus could produce such a pronounced luminosity, however, only deepened the mystery. This strange brightness profile led Loeb and his colleague Araquito to consider a possibility that would radically separate 3I/Atlas from the typical population of icy wanderers. If the object's nucleus is luminous in its own right, it might be producing light rather than merely reflecting it. Based on calculations, Loeb estimated that the observed glow would require an energy output of around 10 gigawatts, comparable to the combined output of multiple terrestrial power plants. No ordinary comet generates that much energy, and sunlight reflection alone could not account for the recorded light intensity. For the object to shine on its own, some mechanism would have to be supplying a substantial and continuous stream of energy. Loeb explored several exotic scenarios that could potentially explain such power. One possibility involved a hypothetical tiny black hole releasing Hawking radiation, but the magnitude of light required is far beyond what such an object could plausibly emit. Another idea involved a fragment from a supernova's core, a remnant loaded with radioactive isotopes capable of producing significant heat and glow through radioactive decay. Although such fragments could theoretically exist, they would be vanishingly rare, and their stability over interstellar distances would be questionable. The most speculative idea, and the one that inevitably attracts public fascination, was that 3I/Atlas might be an engineered spacecraft, perhaps powered by a nuclear reactor or some advanced propulsion technology, shedding dust acquired over its long voyage. While Loeb did not claim this interpretation as fact, he argued that it should not be dismissed outright, especially given the object's unconventional behavior and the scientific value of entertaining hypotheses that matched the data rather than ignoring them. Adding to the intrigue, 3I/Atlas has taken an unusual path through our solar system. Its trajectory has carried it past both Earth and Jupiter, almost as though it was navigating through the planetary system rather than simply plunging straight through it. In early October of 2025, it is projected to pass within roughly 29 million kilometers of Mars, a distance that astronomers consider extraordinarily close for an interstellar object. This close approach offers an unprecedented observational opportunity. NASA's Mars Reconnaissance Orbiter, equipped with a powerful HiRISE camera, is already scheduled to observe the object during its pass near Mars. These images may become the most detailed look humanity has ever captured of an interstellar visitor, potentially revealing surface features, rotation patterns, or signatures of activity that Earth-based telescopes cannot resolve. Observing the object from Earth at that time will be far more difficult, as 3I/Atlas will appear close to the Sun in the sky, making it nearly invisible against the overwhelming brightness. Mars, therefore, becomes the perfect vantage point for gathering crucial data. Despite the excitement, the majority of astronomers maintain a more conservative stance. David Jewitt, a scientist who played a key role in analyzing the Hubble imagery, argues that the object's behavior may still fit within the boundaries of cometary physics, albeit in an unusual way. Jewitt suggests that sublimation occurring on the sun-facing side of the object might produce a coma without forming a tail. If the released particles are extremely fine or evaporate too quickly, they might not survive long enough to be pushed into the familiar tail shape by solar radiation pressure. This explanation would allow the object to remain a comet without requiring exotic energy sources or technological interpretations. Yet even Jewitt acknowledges that the steep light profile remains an unresolved puzzle. Traditionally, a coma exhibits a gentle decline in brightness from the nucleus outward, but 3I/Atlas shows a sharp decrease consistent with a much more compact light source. This ongoing debate echoes the scientific controversy surrounding Oumuamua, the first known interstellar object, which passed through the solar system in 2017. Loeb argued that Oumuamua demonstrated physical behavior inconsistent with any known natural object, including its unexpected acceleration and pancake-like shape, leading him to propose that it could be an artificial probe. Many scientists disagreed, offering natural explanations such as frozen hydrogen, nitrogen, or fractured debris from a planetesimal. Still, none of the natural models fully answered every observational question, and the controversy remains unresolved. The discovery of 3I/Atlas now reopens those debates, presenting another interstellar visitor with anomalies that resist straightforward explanation. As telescopes and spacecraft prepare to study 3I/Atlas in greater detail, the scientific community is faced with a thrilling dilemma. Is this simply another comet behaving in a strange but natural way? Or could it represent an entirely new category of interstellar object, one that might include exotic physical processes or even technological origins? Each piece of new data brings the possibility of solving the mystery, yet also the potential to deepen it. The object's brightness, composition, path, and energy signature will all be examined with unprecedented scrutiny. If Mars Reconnaissance Orbiter captures surface detail, it might confirm whether the nucleus is icy, rocky, metallic, or something unprecedented. Spectral data could reveal the presence of elements or compounds that suggest unusual chemistry. Photometric measurements could uncover whether the brightness pulsates, rotates, or fluctuates in a way that corresponds to artificial mechanisms. Whatever the outcome, 3I/Atlas promises to reshape scientific understanding. If it turns out to be natural, it will expand the known diversity of interstellar bodies and force researchers to reconsider how such objects evolve and survive across the galaxy. If it turns out to be technological, it would represent one of the most profound discoveries in human history, raising questions not just about life beyond Earth, but about travel, exploration, and communication in the universe. Even a natural explanation would be extraordinary, given how unusual the object already appears. For now, astronomers continue to observe, calculate, and debate, knowing that the universe often defies expectations, and that each anomaly is an invitation to learn more. 3I/Atlas, with its forward glowing coma, missing tail, steep light curve, and mysterious energy profile, stands as a reminder that the cosmos is vast, surprising, and far from fully understood.